Hello and welcome back to the Cracking FAANG YouTube channel. Today we're solving Leetcode 950, reveal cards in increasing order. You are given an integer array deck. There is a deck of cards where every card has a unique integer. The integer on the ith card is deck of I. You can order the deck in any order you want, but initially all the cards start face down in one deck. You'll do the following steps repeatedly until all the cards are revealed. You'll take the top card of the deck, reveal it, and then take it out of the deck. If there's still cards in the deck, then put the next top card at the bottom. And if there's still unrevealed cards, then go back to step 1 and repeat, otherwise stop. Return an ordering of the deck that would reveal the cards in increasing order, and note that the first entry in the answer is considered the top of the deck. So let's work through an example and kind of go through our intuition here. So we have our deck, 17, 13, 11, 2, 3, 5, and 7, and we want to basically return 2, 13, 3, 11, 5, 7, 11. And we'll see why that is the answer in a second. So what we want to do is basically return the cards in sorted order. So in this case, what is the sorted order here? It should be 2, 3, 5, 7. I think it's then, 11, 13, and then 17, right? So knowing that this is our final result and knowing how the game is played, we can actually go backwards from our solution here and basically rebuild the output based on kind of where we want to start and what the rules of the game are. So we can kind of just undo the rules of the game, and we should be able to get to our final solution. Now, the way that we're going to do this is we're going to make use of a deck. And what the deck is going to do is represent the numbers that we want to process. So in this case, it's going to be our sorted array. And we're going to keep track of all of the indexes that we need to insert into our answers. So we're going to have so we're going to have an array which has the indexes for each of the elements that we need to populate in our result. So in this case, we have 6 elements, 1, 2, 3, 4, 5, 6, 7, 7 elements. And we need to populate this into an answer. So obviously in the beginning, we haven't done anything. So our answer will be 0. So what we want to do is we want to process our queue, but apply the rules of the game such that we basically reverse them to build out our solution. And we're going to use our queue here to basically keep track of the index that we need to insert from. And here's what we're going to do. We're going to go left to right over this queue, and we're going to play the rules of the game. So remember that the first rule of the game says that you take whatever's at the top, you're going to pop it from the queue, and then basically that, is going to be your first one. So in this case, we're going to pop the first element, so the 2, and this is at the 0th index. So this should go at the 0th index in our solution. So this should be the first card that we show. So now that we've gotten rid of that, our next index is going to be the 1. But remember in our game that the next card of the deck should go at the bottom. So we're going to move the first index. So the element that will go to the first index, we'll process that later. We're going to move it to the end of our array. Now we have basically to repeat the game. So we pop whatever is at the front here. So the element at the second index will be 3 because that's what's currently at next to be processed. So we're going to pop whatever's at the second index, put at the second index whatever was at the top, which was the 3. So this will become 3, and we'll repeat the game. So this 3 now becomes the card that goes to the end. So now 3 will go to the end here, and we'll process it later. So now we have the 4, and again, we need to pop and place into the 4th index whatever's at the front of our sorted array. And so basically this is going to be 5. So 0, 1, 2, 3, 4. So the 5 will basically go here. Now remember, we pop this, pop it. And we need to pop from the other one as well because we just processed this 5. Now remember, the next card will go to the bottom. So we need to move it to the end of our array. And then we now have the 6th. So at the 6th index, we want to put our 7. So we're going to pop again from the array. So at the 7th index, so 0, 1, 2, 3, 4, 5, 6. Whoops, am I missing a 0? 0, 1, 2, 3, 4, 5, 6. There should be 7, right? Okay, I think I'm missing one. No, wait. Sorry, am I missing one? No, I think it's... Yeah, it should be here, the 7th. Okay, yeah, I think that's fine. Yeah, this will be the 13. Yeah, okay, never mind, we're good. Sorry, confused myself. Okay, so we just did that, which means that the next index, we want to basically move the 1 to the end again. So we're going to move the 1 to the end because that's the one that comes up next. So now the 3 gets popped, and we want to put the 11 at the 3rd index. So 0, 1, 2, 3. So the 11 will go here. And then we basically repeat the process. So the 5 will now go to the end because that's the next card, 5. And then now we pop the 1. So the 1 at the first index, we want to put 13 here. And then basically now there's only one element left, so there's nothing for us to do except insert at the 5th position, 5th index, the 17. So now our array will fully be processed, and this is our final solution. Now if we actually play the game, we can see that this will give us the answer in sorted order. So for example, we first pop the 2, then the next card goes to the end. So that means that the 3 is next, so we pop that. Then the next one goes to the end. So now here we have 13 and 11. So we've popped all of this. Now the 5 goes next. Then the 17 goes to the end. Then the 7 gets popped and added. Now we have, oops, this should be 17. Now we have, let's see, now, yeah, the 13 will now go to the end. Then we pop the 11, but now the 17 goes to the end again. So then we pop the 13, and then obviously there's just 17 left. So there you go. So that is how we got our final solution. So like I said, the way that we want to do this is we're going to sort the original array, and then we're going to keep a basically a helper kind of array, a deque, to keep track of the indexes we need to insert. And we're basically going to apply the rules of the game to the the original sorted array. And then once we do that, using our deque to help us, we can basically reconstruct the solution based on kind of the rules of the game by basically just undoing it. So that is how we're going to do it. Now let's actually go into the code editor and type it up. Okay, let's now code this up. So let us define a variable to basically just keep track of the length of our deque, because we'll need it here. So we're going to say n equals the length of our deque. And now the queue that we're going to work with, we need to basically create one. So we're going to say collections.deque. And then we need to basically populate into this queue the indexes we want to work with. And this is just going to be the indexes for however long the original deque is. So we're going to say for I in range of n. We're just going to say, whoops, we're going to say queue.append I. And now remember that we work with a sorted deque. So we're going to say deque.sort. And now we need to actually put the cards at the correct index in our result. So let's define the result. So this is going to be an empty list of length n. And we need to basically go through our cards and basically play the game such that we can get our final result like we saw in the example that we worked through. So we're going to say for card in the deque. We're going to say we need to reveal the card, right? So the first step is to reveal the card. So we're going to reveal the card and we're going to put it into result. So remember, we're going to be working off of the index in queue. We work side by side, the queue and the deque. So we're going to figure out which index we need to use. So it's going to be queue.popleft. That's going to tell us the index that we want to insert the card in. And then what we want to do is basically we want to say, okay, if we still have a queue left, then we need to move the card that's at the front to the back, right? So the way that we're going to do that is we're going to say if there's still something in the queue, then we want to say queue.append. So we want to move to the back of the queue, whatever's at the front, because that element needs to get processed last, right? Because when you flip a card, then the next card goes to the bottom. So we're going to say queue.popleft, and there you go. So we move it to the end, And basically this is going to repeat for all of the cards, and we will basically get our result, and all we need to do is now just return the result. So that is that. I think this will run. Let's submit it. And we are, okay, accepted. Perfect. So before we go, what is the time and space complexity here? So the most expensive operation here will be the sort, which of course is going to take big O of n log n, where n equals to num cards in Deque, obviously. And for the space complexity, well, first of all, we have to sort, which takes big O of n space, and then we also store the result and also the queue. So it's going to be big O of n, n as well. So that's how you solve this question. Pretty cool. A little bit tricky when you first see it, but once you realize that you can actually just sort the array and then recreate the result based on kind of the rules given to you, then it's actually quite straightforward. It's just figuring out how this part works to get it right. It's a bit tricky, but anyway, you have the solution video now, so hopefully it makes sense. If you enjoyed the video, please leave it a like and a comment. It really helps me out with the YouTube algorithm. Otherwise, I will see you in the next one. Bye.